So the last part of this chapter is called noble gas notation. And noble gas notation is basically a shortened way of writing electron configuration using a noble gas, which are found in group 18. So your noble gases are helium, neon, argon, krypton, xenon, and radon. So these are going to basically get the ball rolling as a shortcut, and then you just add on to them. So you have to use the noble gas that comes before the element in question. And that noble gas, its symbol is going to go in squared brackets or squared parentheses. So the squared brackets actually represent the noble gases electron configuration with just the symbol, and then you add on the rest. Unfortunately, you first have to know the noble gases electron configurations. So you're definitely going to want to write these down together so you can refer back to them. For the test, you will be able to use the noble gases and then add on. So this is just the noble gases. So our first noble gas is helium. It has one electron. I'm sorry, it has two electrons. So its electron configuration is 1s2. Neon. Neon is atomic number 10. 10 electrons, so its electron configuration, 1s2, 2s2, 2p6. Argon, atomic number 18. 18 electrons, 1s2, 2s2, 2p6, 3s2 gives us 12, 3p6 gives us 18. Have you noticed anything yet about the noble gases electron configuration? The very last portion is always full. So 6p, that's full. 2s2, or I'm sorry, 1s2 for helium. All right, krypton, atomic number 36. Try it out. Check where I'm at, 2, 4, 10, 12, 18, 20, 30. Whoops. Make sure you're following that chart. So I was at 3D. Now I've got to go down to 4p, and I'm going to fill it with 6. So that is krypton's electron configuration. Remember, we're not doing anything shortened yet. You have to know the noble gases electron configurations first. Xenon, 54. I have to check because I'm not sure if I went too far. 10, 12, 18, 20, 30, 36, 37, 38, 48. That's good. Okay, so once again, a full last orbital. And last but not least, the longest is radon with 86. I'm going to stop right there and check. So got 2, 4, 10, 12, 18, 20, 30, 36, 38, 48, 54, 56, 70. So I'm at 4F14. 5D10 gives me 80. And then 6P6 gives me 86. So you have to know those first. Okay, now that we know the electron configurations for the noble gases, we can use a shortcut. So actually using noble gas notation, which is a shortcut. The first example is B, boron. It's got 5 electrons. You have to look at your periodic table. Which noble gas comes before boron? So you have to go backwards. That would be okay, so this is boron's electron configuration. You already wrote that down in the very beginning of the chapter. So we're going to use helium because it comes before boron. Helium is 1s2. So when you write noble gas notation, you're going to put in the bracket helium, He, that's 1s2. This is taken care of. Then all you have to do is take the rest of this and write it after. So helium is 1s2, and then we write 2s2, 2p1. It doesn't seem short right now, but we have such a short electron configuration. So helium has 2 electrons, plus 2 is 4, plus 1 is 5, and that is boron. Okay, so you have to look at the noble gas that comes before it. What is that noble gas's electron configuration? Where is that at in the actual electron configuration, and how do you shorten it? Okay, let's try carbon, C. Atomic number 6. You already did this as well before. So you can refer back into your notes for the actual electron configuration of carbon, which is 1s2, 2s2, 2p6. Once again, helium comes before carbon. So we're going to take our square bracket, He, helium. He is representing 1s2, which is right here. And then you just fill in the rest. So 1s2, and then 2s2, 2p2. Helium has 2 electrons, plus 2 gives me 6. As I said, it doesn't seem like a shortcut right now, but that's because you're writing so small of electron configurations. Let's try calcium, a bigger one. Calcium's atomic number is 20. You did this before in your notes. Here is the electron configuration for calcium. Okay, calcium is number 20. The noble gas that comes before it is argon. And this is argon's electron configuration. Now this will be a shortcut. So argon's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Right here. Same thing. Okay, so the yellow, as I said, the yellow is going to be put into the bracket. So I'm going to put AR, argon. That is representing all of this. Also representing all of this. That leaves me with 4s2, which I add on to the end. That is why it's a shortcut. The noble gas notation for calcium is argon 4s2. Okay, argon has 18 electrons, plus 2 gives me the 20. That's how it's a shortcut. All right, try our big one, mercury. This had 80. Remember how long it was to write the electron configuration? I'll remind you. There it is. Okay, the noble gas that comes before mercury is xenon. So once again, you have to know xenon's electron configuration, which goes the whole way up to 5p6. So I'm going to highlight up to 5p6. That is my bracket. So Xe in a bracket represents everything up to 5p6. And then I just take the rest of it and add it to the end. So this would be xenon, 6s2, 4f14, 5d10. Xenon has 54, plus 2, 56, 66, 76 plus 4 is 80. Try yttrium. You also did this one. I'm doing ones you've done before. You should have their electron configurations in your notes. This is yttrium's. The noble gas that comes before it is K krypton. Krypton's electron configuration goes up to 4p6. So I'm going to highlight up to 4p6. That is taken care of by the bracket. So Xe xenon will go in the bracket. I'm sorry, Kr krypton will go in the bracket. And then you just add in the rest. Krypton 5s2, 4d1. So krypton has 36, 37, 38, 39. That gives us yttriums. Keep in mind, if you don't do the electron configuration right, you potentially could mess up the noble gas notation, or if you use the wrong noble gas. Okay, I wouldn't want to use argon because argon is smaller. It only goes up to here. I would have to write the rest of this stuff. I have to write all of this. Okay, you want the shortest cut you can take. Right, try copper Cu, another one you've done before. 29 electrons. Refresh your memory. This is its noble gas notation. This is its electron configuration. You have to know that. The noble gas that comes before carbon is, before copper is argon. Argon goes up to 3p6. And then I just have to write the rest. So my noble gas notation for copper is argon in brackets. And then I take the rest and write it on. 4s2, 3d9. Whoops. Make sure you're actually copying your electron configuration correctly. This is a doozy one for me. Okay, so argon has 18, plus 2 is 20, plus 9 is 29. It's a shortcut. All right, antimony. Try it out. Pause the video, check your work. Antimony has 51 electrons. Refresh yourself, you've done this one too. The noble gas that comes before antimony is krypton, going up to 4p6. So that's taken care of by the bracket. So I put krypton in the bracket, and then I just write the rest. 5s2, 4d10, 5p3. And I check my numbers. Krypton has 36, 37, 38, 48, 49, 50, 51. All right, let's try 2 more. Iron, Fe. Try it out. We also did this one before. Pause the video. Okay, the noble gas that comes before iron is argon. Goes up to 3p6. So there's 3p6. So in my bracket, I put Ar, argon, and then I fill in the rest. 4s2, 3d6. Argon has 18, 19, 20, 26, which matches iron. Okay, last one. Chlorine Cl. Another one you did before. I'm doing all the ones you've done before because you have to know the electron configuration in order to shorten it. I know you're thinking, well, that's not a shortcut then, but it can be if you get better at this and you start memorizing them. Okay, noble gas that comes before chlorine is neon. Neon goes up to 2p6. So in my bracket, I write Ne. That is representing 1s2, 2s2, 2p6. And then I add the rest on to the end. And I check. Neon has 10, 11, 12, 13, 14, 15, 16, 17 for chlorine. Okay, so like I said before, if you're confused at all, get a hold of me. If you want some extra practice, you could try these 5, do their electron configuration, and do their noble gas notation. You can always check your answers with me. If you're really ambitious, you can also try these 5. Same thing, do the electron configuration and their noble gas notation. So that is the end of chapter 4.